Hello students, in this video we will discuss take the problem 2, this example, and then we solve this differential equation by the series methods. Okay, and then y dash minus the 3x square y is equal to 0. Okay, then we take the solution of this differential equation as y is equal to, from n is 0 to infinity, is cn and x key power n. Okay, then we take the derivative first time because here is only first time derivatives. Then this is a summation from n is equal to 1 and n cn and x key power n minus 1. Okay, then we put this true value into these equations. Okay, and then summation from n is equal to 1 to infinity and n cn and x to the power n minus 1 minus 3 and summation and x square also here, and from n is equal to 0 and cn and x to the power n is equal to 0. Okay, then n is equal to 1 and cn and x to the power n minus 1 minus and 3 from 0 to infinity. Then this is the x square. Now then we add it to this x to the power cn and x to the power n and plus 2. Okay, and then is equal to 0. Okay, then first we put the limits of this one here. Then this is x to the power 0. Okay, and now we put here, then this is x to the power 2. Now we can expand this term by 2 to have the same power of this. But then we can write this equations is, first we write expand this terms. Okay, then this is c1 plus c2. We expand this for n is equal to 1, then this is c1, and for n is equal to 2, this one's. Okay, then from n is equal to 3, we start from n is equal to 3 and n cn and x to the power n minus 1 minus 3 from n is equal to 0 to infinity cn and x to the power n plus 2 equal to 0. When we put the value of limits here, okay, then this is n is equal to 1 and n is equal to 2. Okay, then this is the x to the power 2 and this is also x to the power 2. Okay, then and let us look here, we compare both sides. Then the c1 and c2 is equal to 0. Okay, and now let us look here, x to the power n minus 1 is, let's n minus 1 is equal to m. Okay, then n is equal to m plus 1, and the limits of m is will start when we put the value of n is here. Then the limits of m is start from 2. Okay, this is for this term. Okay, now for this term n plus 2 is equal to m. Okay, then the n value is m minus 2, and the limits of m, when we put the limits of n here is 0, then this is the m is also 2. Okay, then we substitute this value into these equations. Then then this is equal to the summations from m is equal to 2, okay, and this is m plus 1, okay, and then cm plus 1 minus 3 summations from m is equal to 2 to infinity and cm minus 2, okay, and x की power m is equal to 0, okay. Then summation from n is equal to 2 to infinity, we take common, then this is m plus 1 and cm plus 1 minus 3 cm minus 2 and x की power m is also common, so, okay. This summation and x की power m is not equal to 0, no, then this coefficient has become 0. No, then the m plus 1s and cm plus 1 minus 3 cm minus 2 is equal to 0, then the value of this is equal to cm plus 1 is equal to this term is transferred to here, then this is 3 divided by m minus 2 divided by m plus 1s, okay. This is the recursion relation, so, and then we find the value of the c1, c2 and c3, okay. Then for m is equal to 2, because the c1 and c2 is equal to 0, okay, then the c3 is equal to 3 divided by 3 c naught, okay, then this is equal to c naught, and for m is equal to 3, then this is c4, we put here, this is the recursion relation, okay. Then this is 3 divided by 4 c1 and we put the value of the ones, then this becomes 0, okay, and for m is equal to 4, and then this is c5, okay, and this is 3 divided by 5 c2, and this is also becomes 0, okay. And then for m is equal to 5, and this is 6, c6 is 3 divided by 6 and c3, okay, then this is 1/2 c naught, we put the value of the c3 as c naught, okay, no, then this is 1/2, this is cancelled to this, okay, and so on. Then the solutions, the eighth solution we will consider is from n is equal to 0 to infinity is cn and x की power n's, then this is c naught plus c1x c2x square and c3x cube and c4x4 up to so on, okay. Then we put the value of the c1, c2, c3 and c4 and up to so on, okay. Then this is c naught, the value of the c1 is 0, okay, and then this is 0, this is 0, and then the value of the c3 is equal to c naught, okay, then this is c naught and x to the power cube, and then the value of the 4 is also equal to 0, okay, and the value of the 6 from x to the power 6 is 1/2 c naught and x to the power 6. The value of the c6 is equal to this, and let us look here, okay, this is the 1/2 c naught and this is 0, this is 0, okay, and the C1 and C1 and C2 is also 0. Then and we can write the another term, and the C7 and C8 is also 0, and the C9 is equal to 1 over 6 C naught. Okay, then this is 1 over 6 C naught and x cube power 9 and so on. Okay, then this we take the C naught as common, and this is 1 plus x cube plus x cube power 6 and x cube power, and divide by 2 here and divide by 6 and x cube power 9. Okay, then y is equal to C naught, and this is equal to e cube power x cube. This series is equal to this. Then this is the solutions. Okay, now we solve this differential equation by the elementary methods. Okay, the equations is y dash is equal to 3x square y. Okay, then we can write this is dy divided by dx is equal to 3 x square y. Okay, then we separate the value dy divided by y, the separation of variable, and 3x square and dx. We integrate both sides, then and this is the natural log of y, and this is here we increase the x its power by 1 and divide by x, and then this is 3 and 3 divided by 3, and then this is cancelled to this, and here and then the integration constant, and here we take the its the natural log of c. Okay, then this is equal to y, the natural log of y is equal to x cube plus the natural log of c, and then we take the its e both side. Okay, this is cancelled, this cancels, and the y is equal to c and e cube power 3x cubes. Okay, and this is the elementary solution, and this is the series methods. Okay, and this too is become equal. Okay, thank you.